In this video, we shall have a closer look at the free fall acceleration. So what is free fall acceleration? Free fall acceleration is the acceleration of a body that is moving under the influence of gravity, such as shown here. This is a falling object. The acceleration for such a motion is constant, and the value of the acceleration is 9.81 meter per second squared if we are dealing with gravitational acceleration due to Earth. Because the acceleration has the same value, namely 9.81 meter per second squared, and its direction is always downward, and therefore the acceleration vector is a constant, the principles of kinematics apply here. Let's have a closer look at this process. Let's look at the following system. So this is the ground level, and you have a ball. This ball is thrown upward, and it's going to go up certain height, stop, and then it will start to come down. Let's analyze these two processes. When the object is moving upward towards that final point, its motion is upward. So that is the direction of the motion. However, we know the acceleration is always downward. Indeed, if we take the line of motion to be the y-axis, so that is the origin of that y-axis, we see that the acceleration of vector can be written as minus 9.81 j hat. Because j hat is the unit vector along the y-axis, the unit is of course meter per second squared. We know that when the direction of motion is opposite to that of acceleration, the object would slow down. So that is that's happening here. The object will go up all the way, slows down, it gets to a maximum height, and then stops there, and then it will start to come down. So now as the object, or this ball, descends, the motion is downward, that arrow right there. The acceleration is also downward. So for the downward motion, the object would speed up all the way from the maximum height to the ground. Of course, in this analysis, we are assuming there is no air friction involved. That would naturally slow the object down. To explain all this better, let's look at the following problem. A ball is thrown vertically upward. So let's assume it's thrown from that level, the ground level. The initial speed is 10 meter per second. How long does the ball take to reach the maximum height? Let's assume the maximum height is reached there. So that is capital H. The initial speed of this ball is 10 meter per second. So that is the initial speed, u. The final speed is the speed of that ball at the maximum height, and that is just 0. If it's not 0, then it would keep on going vertically upward, and that wouldn't be the maximum point. One other thing that we know, as the ball goes up to the maximum height, the acceleration is downward, as we have discussed, whose value is given by minus 9.81 j hat meter per second squared. We want to determine the time it takes to get from the launching point to that maximum height. Since the acceleration is constant, kinematics apply. And obviously, the equation that we use is the first equation of kinematics, namely v equals u plus at. V is the final speed, that is 0. U is 10. We are told that it is 10. A is minus 9.81. Note, the motion is upward, acceleration is downward, so the minus sign right there, and t is capital T. Solving for t, we get 1.02 seconds. So that is the answer for part A. The time is 1.02 seconds to go from that point to the maximum height. Part B. What is the maximum height reached by the ball? Namely, what is that distance? For this, we can use the second equation of kinematics, namely the distance covered equals half acceleration time to cover that distance squared plus the initial speed times that time. So in this case, we want to find that distance. Delta y is your h. Half, remember, the acceleration is negative 9.81. The motion is upward, acceleration is downward, thus the negative sign. Time is capital T, which we already found. That is 1.02 squared. Initial speed is 10, that is given to us, times t, which is again 1.02, which will give you 5.1 meters. So that is the answer for part B. Maximum height is 5.1 meters. Part C, how long does the ball take to reach a height 3 meters above the release point? What that means is, assume that the object is, let's say, here, where it is 3 meter mark from the ground. What is the time it takes to get there? We can use this second equation of kinematics to get the answer that says the distance equals half acceleration time to get there squared plus the initial speed times time to get there. So let's substitute the details. Delta y is, of course, 3. Acceleration is minus 9.81. T, we don't know. The initial speed is 10, again t. So we need to determine that t. This is a quadratic equation in time, so let's rearrange all the terms. So that term is quite simply 4.91 t squared. Let's bring it to that side. This one becomes minus 10t after you bring it to the left, and you have the 3 there equals to 0. So let's solve the quadratic equation. B is your minus 10, so minus b is like 10 plus minus square root b squared, so that is 100, that is like minus 10 squared, minus a 4. A is that number, 4.91 times C. And to that, you divide the whole thing by 2A, which is 2 times 4.91. I have just make use of the roots of quadratic equation formula here. So what you have is 10 plus minus 6.409. So this entire square root has a value of 6.409 and divide by 9.82. And there are two solutions. The first solution is 0.36 seconds and the second answer is 1.67 seconds. So these are the two times the ball take to reach that height above that release point. Of course, this is not really surprising because the ball passes twice through that 3 meter mark, once on the way up, that corresponds to that time, and once on the way down, that corresponds to the second number. And that solves the problem. Thank you for watching.